Section 2.4, Writing Equations of Lines. There are two methods that we can use to write equations of lines. We can use the slope-intercept form, and we can use point-slope form. So to use slope-intercept form, we're going to start with that slope-intercept equation, y equals mx plus b. And the first thing you need to do is you'll be given an ordered pair and a slope, or you may be given two ordered pairs, and you'll need to find the slope. In any case, you're going to plug in the ordered pair x and y for the x and the y in the equation, and you're going to plug in the slope m. Then you're going to solve for b, the y-intercept, and after you've found b, you're going to go back and you're going to rewrite the equation using m and b, the numbers you've found for m and b. I prefer point-slope form. Point-slope form is y minus a y-coordinate equals the slope times x minus the x-coordinate, because this one you don't have to go back and rewrite anything. You are just going to plug in the ordered pair that you're given, x1, y1, and the slope, and then you're going to distribute and simplify, solving for y, and then you'll be done. Once you've distributed the m and brought the y1 over and combined like terms, you'll have your equation. So I'll demonstrate both methods, but after the first couple examples, I will probably more be using the point-slope form. So if we're going to write the equation of a line that passes through the given point and has the given slope, to begin with, I will demonstrate using slope-intercept, so y equals mx plus b. So the first thing we're going to do is plug in -1 for the y. Our slope is -1/2, and our x-coordinate is 8. And we don't know our b, so that's what we're solving for. So when we solve this for b, we should get b equals 3. And now that we have our b and we have our slope, we could write y equals -1/2 x plus 3. So that's one method. The other method is using point-slope form, so y minus the y-coordinate equals m times x minus the x-coordinate, and again y minus -1 equals -1/2 x minus 8. When I distribute, the double negative is positive, -1/2 x plus 4. Subtracting the 1 from both sides, I get y equals -1/2 x plus 3. So both methods obviously result in the same equation. Now, one other thing we might have to do is get our equations or our lines into standard form. And remember, standard form is ax plus by equals c. So the first thing we need to do is getting our or our x and y term on the same side of the equation. If I add the 1/2 x, I'll get positive 1/2 x plus y equals 3. But remembering now that we are not supposed to have a fraction, a, b, and c are supposed to be integers, I will have to multiply both sides of the equation, everything in the equation, by 2. And so then I'll get x plus 2y equals 6. And this would be the form of the equation in standard form. So all three of these are the same line. These, in fact, are the identical form: slope-intercept form, standard form. Demonstrating both methods again. First I will use y equals mx plus b. So again, 6 equals, my m is 4, my x is -1, and I need to find b. And so now if I just go ahead and solve this for b, I'll find that b equals 10. And then I'm going to write y equals m, which is 4, x plus b, which is 10. Now if I go ahead and use point-slope form, again plugging in the y-coordinate for my y, the slope, and the x-coordinate, and solving this for y, I get the same equation. Now writing this in standard form, if I bring the x term over, -4x plus y equals 10, I do have integer solutions, or integer values for a, b, and c. I could also write this with a leading positive value. If I were to multiply through by -1, I had to get 4x minus y equals negative 10. So now we have actually 3 different versions of the exact same line. Next, we're going to write the equation of the line that passes through negative 2, 1 and is parallel to y equals 3x plus 1. So the only thing that we need from this equation is the fact that the slope of this equation is negative 3. And so remember, if two lines are parallel, then they must have the same slope. I'm not using any other information from that line because I want to write the equation that goes through this point and this that's parallel, so it has the same slope. So once I've gotten the slope from it, I'm done with that equation. And so now again, I'm going to demonstrate writing the equation. I'm going to, from this point out, solely use point-slope form. If you're more comfortable with slope-intercept form, that's fine. Keeping in mind from those last two examples, no matter which method you use, you should get the same equation as I do. So plugging this in and solving this for y, I get the equation that's parallel to this line is y equals negative 3x minus 5. So it has the same slope, but it's going to have a different y-intercept because it's parallel. It's not going to be the same line. We're doing the same idea. Again, we're going to write the equation that goes through the point negative 2, 1, but this time is perpendicular to y equals negative 3x plus 1. So again, the slope of this line is negative 3, but we want a perpendicular slope. So remember, the perpendicular slope, the slope that we're going to use, is the opposite, so positive, and then the reciprocal of 3 is 1/3. So we're going to use a slope of 1/3 through this point. And now we're done with that equation. We have our point, we have our slope, we can write an equation. So go ahead and do that and check back and see if we come up with the same equation. So the equation of the line that goes through the point 2, 1 and is perpendicular to y equals negative 3x plus 1 is y equals 1/3 x plus 1 2/3. Now we need to write the equation of the line that passes through the points negative 820 and negative 615. But let's think for a second, what do we need to write equations? We need a point and a slope, but we're given 2 points. Well, that's simple enough. We can find the slope. So let's go ahead and do that, the change in y over the change in x. Now we have a slope of negative 5/2, and since both of these points obviously are making up the line, they're both on the line, we can write our equation using either point that we want. So go ahead and use our slope of negative 5/2 and use either one of those points and write an equation, and we should all come up with the same equation. And I just had an error that I corrected. I had written that this was negative 5/8. It's negative 5/2 x. Adding 20 to both sides, we get that our final equation through those points would be y equals negative 5/2 x. And now an application. In a chemistry experiment, you record the temperature of a compound to be negative 5 degrees 1 minute after you start the experiment. 6 minutes after you begin the experiment, the temp is 20 degrees. Write a linear equation that models the temperature of the compound in relation to the elapsed time. Now with this word problem, we need to be able to set up two sets of ordered pairs, but we need to know which number, which quantity goes for the x-coordinate and which one is going to represent the y-coordinate. Well, let's remember that the x and y is the independent and the dependent variable. So we need to look at the problem and determine which quantity depends on the other quantity. So we're dealing with time and we're dealing with temperature. So does the temperature depend on the time, or does the time elapsed depend on the temperature? Well, it should seem somewhat obvious that temperature is going, or time, excuse me, is going to happen no matter what changes are going on. So in this case, the time is going to be our independent variable because the temperature is going to depend on how much time has elapsed. So now our two ordered pairs, 1 minute after we started the experiment, the temperature was -5. And then it says that 6 minutes after we started, the temperature is 20 degrees, our temperature. And so now we have two ordered pairs and we can write an equation, so go ahead and do that. So remember that in order to write an equation, we need a point and a slope. So since we only have 2 points, we need to find our slope. So our slope is going to be 25 over 5, which simplifies to 5. And now we can use our slope and either one of these points and go ahead and write an equation, please. So our equation is y equals 5x minus 10, where in a manner of speaking we have defined our variables up here, but x represents the time elapsed and y represents the temperature. So we need to start getting in the habit of defining our variables. And finally, you have $6 to spend on drinks and a salad at the school cafeteria. The drinks cost $1.25 each, and the salad costs 20 cents per ounce. Write an equation that models this. So this is, to some extent, an exercise in figuring out how to define your variables. So our overall cost is going to depend on the number of drinks we have, so we can let one of our variables represent the number of drinks. And our total cost is also going to depend on how much of a salad we get. So our y is going to be our ounces of salad that we're going to get. So using the model of unit price times the number that we're getting, that won't work because x is the number of drinks. So it's going to be the price. It is going to be the price times the number. I don't know why I did that. Plus the price times the number, and that's going to equal the total cost. So the price of the drinks is $1.25 times the number of drinks, plus the price per ounce of our salad is 20 cents per ounce, times the number of ounces of our salad, and that's going to equal our $6 total. Kind of goofed up on the last one. I apologize for that. So that's the end of our notes for this section. Remember, if you have any questions, please make sure you come to class with those, and also remember to go back and do the notes check. Thanks, and we'll see you tomorrow in class.